Hello everyone, my name is Kiran Rawat. So today I'm going to present the second Capstone project that is related to exploratory data analysis. As per the project requirement, we need to do data analysis on given data set. So the data set that I have chosen is related to Amazon Prime Video platform. Basically, let's talk about EDA first. So when we talk about EDA, exploratory data analysis is used to analyze and investigate the data, right? We are having the raw data, then we are going to manipulate the data, having some insight over the data, so that we can do some analysis that in which things we need to focus in the future, right? So as per the data that is given, this data is basically all about the content that were available on this platform till the date of 2022. So after the analysis, basically the project summary will tell you this project aims to uncover the insight from Amazon Prime Video's library. We are having movies, shows data on this platform. So we are having two file here, credits and titles. So in the titles, all the data is related to movies like IMDb score, runtime, A certification, and a TMDB score. And for the credit, all the cast information is available in this data. Okay, so after the analysis, what I analyze that what genre is more popular, what country is basically leading in the content they are giving us on the platform, what basically a certification is most popular among the users, what user prefer, how is the rating variability is going on as per the movies, right? I also attached two link over here for the files. So every time like I am running these files, I just mounted mounted the drive over here. Okay, so it will give me the liability to have like run it smoothly. Okay, this is the GitHub link for the data set. You can just click on it and you will be having the project detail over there also. So the main objective for this project is to study the shows and movies content available on Amazon platform, Prime Video platform, and find useful pattern and insight. Okay, so we need to understand that types of shows are popular, how the content is spread across different region, how the platform content has changed over the time. These findings can help streaming platform and content creator make smarter decision as per their user engagement, right? And which reasons they need to focus on. So the problem statement that were given in the data was related to content diversity, trends over time, and IMDb rating. So let's get started with the EDA process. Okay, first we need to import the libraries. I am going to use four libraries over here to manipulate the data. I'm going to use Panda and NumPy. Pandas and NumPy, and for the visualization we are going to use Matplot and Seaborn. So first what we need to basically loading the data set. Okay, so credits and titles we are having. So I already told you that this related to the cast data. We are having the info here. We have four columns over here, and for the head we can see 10 rows basically, but I have given the argument 5, so that is why I'm seeing 5 rows. We can see ID, movie ID, basically it is telling you about title, the movie title, type show if it is a show or movie, description what basically it's a short description what the movie or show all about. A certification basically is giving the like if it is TVPG, so basically TV content that needs parental guidance. There are also some missing values. Then runtime we are having, release year we are having, same like that we are having IMDb ID, seasons. So mostly seasons are available only for shows. So what I do personally when we are doing EDA, I always try to open the Excel file, because Excel will give you like more. If you're just looking on the data, you can have different, you can understand more about your data. Like let's say if I'm talk about type, so there are, we can see like movies are, we are having more movies if we compare it to the show, right? So these kind of a data we can see, like genres we can see, for the shows and movies we have number of genres, more than one genre are there. US is the country that is like providing more content. And also we can have where the missing values are. So basically it gives you the liability, to have a better understanding of your data. So I always try to open an Excel sheet while I'm doing EDA. Okay, so same for the titles. We are having all the columns over here. Yeah, also checking the data type, if data type is correct or not. Okay, so after that I checked for the duplicate values. For credits we are having duplicate values because there are a movie which can have like a number of a cast, number of actors in the movie, right? So movie ID will be the duplicate values. So okay, same goes for the titles. Basically title is not having any duplicate values. Sometimes it happens, for example the column can have same values like US we can see, right? Then we are going to talk about the save shape. So title is having 9,000 something rows, 9,871 and 15 columns. Same for the credits. This is the all about the data set that we knew after the looking on the data set. The data set contains movie, TV available on Prime Videos, gives the detail like TV, movie, IMDb ratings and more. Most of the content is movie, and most common genre are drama, comedy, action. Okay, so I also noticed that show common from the US, but there are also titles from other countries as well. Some columns had missing values like A certification, season, and TMDB score. So now understanding the variable, so we can see person ID is int 64, it is name. So I used info method, info function here. Okay, so for the describe data it is better if you are just describing, if you are using describe function, a describe method basically for every column, because then you are going to have like better understanding. Okay, so I have used described like while I was doing data wrangling. So we are going to see that also afterwards. Okay, so these are the variable description. So you can look it for it. What most interesting part is, what I did when we are checking the unique values, as we are having like 15 columns in titles, 4 to 5 columns in graded. So what I did, I used the for loop over here to see the unique values. So let's say if I talk about roles, so there are two roles, two type. Basically it is a categorical column, so actor, director were available there. Same goes for titles. We can see like different countries, also we can see different genre, these are the IDs. We also can see countries over here. Then we can see A certification and everything. Okay, let's talk about now data wrangling code. So data wrangling is basically when we are working on the raw data, and we are basically structuring the data for our analysis. So what I did, I firstly I divided the columns into two, numerical and categorical, so I can handle the missing values or tidiness issues over there. Also we can see like there are two issue I did find. First was tidiness. Basically tidiness, let's say genre and production list is given, let's say. Okay, so this is like genre, so we are having this list over here. Okay, so this is the problem. Also we can have like we have number of countries over here, it is also it is in the list. So it is better if it is just a string or object, right? A string, right? um, then we talk about credits, role, actor and director. We are having two categories. Qualities issue, we are having like some missing values, some rows were missing, TMDV score and IMDb votes contain missing values. So okay, so this was all about the data accessing. Now we talk about the data cleaning. So okay, so first we need to make some copies. So we can have like access of the original file also. So if there is some mistakes you are going to do in EDA, you can go back to your original file. Okay, so first what I did for the genre, I just use some strip method and replace the inverted commas with no values. So then we are going to have genre like this in a string basically in a string manner, so we can just extract data more easily. And then I also applied, as I can see that number of genres is available for one movie or one show. So what I did, I add one more column over here for the genre count. So I just basically split the data first, and then I count with the land function. So this is the genre count, and then I insert this function to next to the genre, next to the genres. Okay. Okay. So okay, if I just do this over here, titles dot head to, so we can see, oh wait, titles dot df, so we can see that we are having the genres count, one more column. So basically it comes under the feature engineering if you are creating new columns, right? So this is the value count of the genre. Now the for the I did the same thing for the production countries, same replace thing, and then it is going to convert in this string, so I can like extract data more easily. Then we talk about null values. So seasons were available only for the shows, so what I did, I cannot just drop the seasons, shows, basically shows rows. So what I did for the movies, I basically write not applicable, so season will not be applicable for the movies type, right? Same goes for goes for value counts. If I'm doing this, we can see like actor and directors are available. Then there were some duplicates over here, but it is not going to create a problem because we need to have this data with us, because if I'm going to make some assumption over actors and directors, then we need to take this data. So I'm not going to drop like IDs over here, because we are having like different IDs for different person. So that is why. Same goes for like character column. I have just fill the NA values with the unknown string description. uh, okay, so this is all about like missing values. Also same goes for the checking rows. If I can drop, what if I have number of missing values column in a same row, right? So what I did is I took a limit, a threshold. If more than three values are missing, then I drop that row. So two rows were there over there, so we can drop like two rows. It will not going to make much effect on our data, so that is why I drop these rows. Okay. Same for a certification. A certification, what I did, I just basically see if there are we can just a set, because we have number of missing values over there. So what I did is see if like missing value impact to what is going to be on data if I'm going to drop it. So it is going to be 65%, so that is why I haven't dropped it. What I did, I just write the missing, where missing, where the value was null. Okay. Now let's talk about the numerical values. As we can see for IMDb score, TMDb score, TMDb popularity, so there are number of numerical values. So what I did, I used some quantile method. So as we can see in the data, some value is beyond, because here minimum value is 1 and the maximum value is 9. So basically we can say that there are some outliers over here. So if I'm going to use mean directly, so it will not give you the perfect result. So that is why what I did, first I removed the outliers. For that I used quartile method. So what I did, 25 first I take 25 percentile, 75 percentile, and then I got the interquartile range, and accordingly we can just get the mean, and then I fill up the null values with that mean only. Okay. Same goes for IMDb votes, TMDB popularity, TMDB score. Okay. Now we can see, after getting the sum for the null values, we can see that now we are not having any null values. Same goes for the duplicates. I already told you that we really don't need to drop the duplicate values before, right? So what all manipulation have you done and insight you found? So most content on Amazon Prime, we see movies, the most common genre drama and comedy. Content producing country USA is there. Many titles do not have a certification, right? TV shows has many seasons, and TV movies, basically it is very common sense that movies will not have the, they can have like parts, but they cannot have the seasons, right? In the dataset genre column written with the extra bracket and symbol, I have written everything what I already explained to you. Then what I did, I merged the data. Why did I merge the data? Because if I am merging the data, this is the merged data that I have already downloaded. So we can have like duplicated rows, but we can just group by it if you are making any insight. So it will give you like a more understanding of the data. Also you can have a more depth analysis. That is why I merged the data over here. Also I write the code for you to download it, right? So you can just, we can have this, like we have these this is the shape number of our rows, but we can group by it. So that will not create the create, that will not going to create any problems, right? Then also I just uh, want to make sure if there is no none values is available, although it is not available, but it is safe to always check. Okay, so let's move ahead with the most important part, data visualization. So for the data visualization, first I did a univariate analysis. Okay, so for the content diversity, what I did, I just group by the data with the movie ID and I take the first row only, right? Okay, so first we need to have like what genre and categories dominate the platform. So we need to understand the genre. Here one thing is very important, what, that I use explode. Why use I explode? Because we were having like different genre, like comedy, thriller, then we are having horror. So it is all available in a like a in a string, but there are number of a values. So what I did, I just use explode. So what it will do, it will going to do it like CTH. So every row will be having these values. So then it will give you like more understanding. Also it will, you can just count it uniquely, right? And then you can have like a more depth analysis. So that is why I use this explode function over here. Okay, so okay, now move ahead. We can see like drama, comedy, thriller, action. These are the genre that is like more popular. These are the five more popular genres as per the movie count, right? Then for the visualization, I used bar plot. Why bar plot? Because bar plot is always giving you the liability, because one is categorical and one is count. So it is easy to compare which genre appear more or less. So bar chart basically is best when we want to, so one compare categories like genre, right? So we can see it, this is like a horizontal bar. Okay, now and the SNS. So basically, SNS is related to Seaborn. Okay, so it is indicating the Seaborn. So I use the Seaborn library over here. So why did I pick this chart? I already told you. What insight? We saw that drama, comedy, thriller are the most common genre on the Amazon Prime. The gain insight on the business impact. So basically Amazon Prime can focus more on popular genre like drama and comedy. Is going to be a one negative point, that like this, in this positive possibly negative insight is some genre may be underrepresented. What happens, because it is not talking about the quality, it is only talking about the quantity over here, right? So the third question was trends over time. So how the Amazon Prime's content library evolved. So we can basically we just group by with the release year, and then we have the title count. So we can see that from 90s to, if we talk about 2019, so it is always evolving, but we can see number of a decline over here in 2000 after 2019, right? So it more likely due to the COVID, as we all know that COVID hits at the time. So that is why it would be the case, right? So line plot, why we are using line plot over here? Because when we basically showing trends over time, so it is always make sure that you are going to use the line chart, because line chart will give you the clarity over it, right? So we can see in between 2019 is the top contribute good number of a title, but after 2019 we can see reducing number of a title. It could be due to the lockdown or corona period. So this insight can help Prime understand which year were most active in the content creation and how the content evolving over the years. Okay, let's talk about the bivariate analysis and multivariate analysis. So what is the distribution of the number of a genres? Number of a genres. So basically I already made a new column with the genre count, right? So what can we see? We can see what if a movie or show falls under a different genres, it would give a good rating or not. So we are calculating that. So what I did, I sort the values with the genre count first, then I took some, not all data because there are 15 columns. So what I need, title, genre title is like a movie, we need a movie count, that is why genre count, IMDb score and type, right? For the graph representation I used strip plot. Why strip plot? Because we can see it will give you the scatter plot first, because we are going to compare in between two numerical column, IMDb score and number of genres. Also it will give you the clarity, it will give you one more parameter hue, so you can add more column to have a better understanding. So we can see shows are having good ratings if they have one or two like a more genres. And what about movies? Movie will not guarantee that if you are including more than one genre, so it will not guarantee with the IMDb, with the good IMDb score. And that is because viewer can get confused about the movie, right? Because shows will be having number of episode, so it will that is why the IMDb score is very high for show, but not for the movies. Let's talk about the TMDB popularity and IMDb score. Okay, so TMDB and IMDb are the movie database only, but IMDb is having the wider range, and TMDB is more focused likely on theatrical release. So they both are movie database only. Okay, so what I did, so first I saw the values with the TM popularity, then I use the same thing over here. So we can see there were top 10 shows as per the IMDb score and popularity, but we also can see there is an exception. What is the exception? Although the Bold and Beautiful is like one of the top 10 show, but it is not having a good rating. It is popular on TMDB, but it is not having a good rating. So it is an exception. So it is not guarantee you, if you are like comparing the data from IMDb and TMDB, it will not give you the same result always. So it is an exception, right? So it is having and it could be a reason. There could be a reason. I think. The people who follows the movie database IMDb, they have not found it yet. It could be a reason. So some shows have high IMDb score and big bubbles, meaning they are both top rated and popular. Other shows with good scores but small bubbles means they are good. Not many people know about them yet. Okay, so this is the thing here, that it is having top popularity score. So basically, the viewer are watching it. Also, the IMDb score is high, so quality wise, it is also good. Then we talk about the correlation in between runtime, TMDB, and IMDB. Okay, so what I did over here, I used the heat map, and we can see that runtime is not having a strong, it is having a negative relationship basically. So IMDB score is not relatable with the runtime, and TMDB is also not related to the runtime. So basically, if a movie is very long or if a show is very long, the runtime is very long, it will not give you the good rating. So basically it will not something that will tell you the quality of the content, right? So I use correlation metric because it helps quickly show the relationship between the numerical values also. Let's talk about the season also. So we want to see if seasons are higher, so IMDb rating is also higher or not, right? So first we need to the filter the data. So what I did, I filtered the data, then I took a value like 3, then I divide into two group, fewer season and more seasons. So then I took the mean, and then I contate the data basically. And talk about the visualization. So I use the box plot over here. Why I use the block box plot? Because first I need to see if IMDb score is dependable on the seasons or not. So also we are going to compare in between fewer season and more seasons, right? So basically, shows that are having seasons more than 3, they have likely to higher IMDb rating than the shows they are having less than 3 seasons. So basically 7.2 something, the average IMDb score for fewer seasons shows, and it is basically 7.8, or you could say 7.7, right? So it is higher than this. Also, we can see the spread of the IMDb score. So spread of the IMDb score with fewer seasons are likely higher than this. For this, like 70, after 75 percentile, they are not very much spreading in between the ratings, right? So that is why I use the box plot over here. So box plot will give you the understanding about it. Also, it will give you the understanding about the outlier also, if there are some outliers which not fall under this category, right? Okay. So if we talk about the insights, shows with the more season generally having higher rating. Rating for shows with fewer season are more spread out, meaning they can be really good or really bad. Some short shows have very low rating, as seen in the outliers that I already told you. So basically, Prime decide to continue popular, highly rated. Let's talk about the impact of actors. So which actor is basically associated with the highest rated content based on the ratings? So first, I filtered the data with the TMDB score and IMDb score. One thing we need to understand over here, that I use the merged data. Why? Because we are having the same actor in different movies, so we cannot skip the rows. So that is why I use this data over here. Okay. Then in role, we were having the director information also, so filter the data, and then we group by the data as per the person ID, because person ID was unique for every actor. And then we took the name also. We have counted the movie count, IMDb score mean and TMDB score mean, then rename the column with the, basically I make it it's like a data frame, new data frame, right? So we have person ID, name, movie count, IMDb score, and TMDB score. Okay, this is the actor by summary. But we can see in this data there are some actors who is having only one movie count. So I think that would not be useful. What I'm going to do, I'm going to filter the data as per their average score, and then the movie count will be the greater than 3, right? So the same thing I did over here. I just sort the data with the average score, and the movie, I filtered the data with the movie count, where like actors were having more than 3 movies or equal to 3 movies. So this is the data, and I took the top 30 data. So basically I took the top 30 rows after sorting the data. So basically this is a very important chart, and this is one of the important, because when we talk about the quadrant, we can use the reference line over here. So I'm going to do, this is the IMDb score, this is the TMDB score. I am going to use the reference line, and we can see the actor who is going to be here, they are having the TMDB score popularity, also they are having the IMDb score ratings higher, right? For the same, like the actor who is coming, like falls under this category, they are having not a very good score in popularity and for the rating also. So I'm going to make it this chart. So this is the actor summary. Now what I'm going to do over here, I need to go to the every row, take the IMDb score, take the TMDB score, also the name, because I want a label, right? So I'm going to take the name also. So for that, I need to run a loop, for loop. The range would be the number of our rows. So we are going to run a loop over here. Okay, so for it, I am going to use matplotlib. I hope you understand. This is one of the fun chart that I made. I used the matplotlib scatter plot. Okay, so for the reference point, I took 8.2. For lines, reference line, I used this method AXH line and AXV line. Okay, now I am running the loop in data. How many times? Total number of a row. So that is why I am using shape. Okay, so I am taking the IMDb score, then taking TMDb score, and then taking the name as a label. So this is all about like to for a better view. So in the chart we can see there were two actors among 30 actors. They were having a good IMDb and TMDb score. Okay, and in this category they are having a good IMDb score, but they are not having TMDB score, right? So really, this will give you the clarity how the top 30 actors is associated with high rated content. Okay. Let's talk about the type of shows and movies, how they are evolving after 2000. So for that, I need to make the pivot first, where I use the release year, type, and IMDb score, average IMDb score. So I am using heat map for this chart. Why am I using heat map? Because first, it is very simple to understand if we are comparing two categories, movies and shows, also how they are evolving over the years after 2000. And darker the color, the rating is high, lighter the color, the rating is less. So we can see, after 2000, if we are talking about movies, so movies are not having like much higher rating, but if we are talking about the shows, they are having higher rating. Also we can see, if we talk about like 2019, after 2019 the quality of the shows also decreasing, and the quality of the movies decreased, but 2022 movies quality increased as per the IMDb score, right? So okay, so this is all about how it is evolving. Also we can see, if we talk about movie and show, they are not having like almost same ratings. So we need to focus on shows, we need to add more shows on Amazon Prime, so people will engage because the rating are good, basically the content is good. So we need to focus on the shows also, because the number of a movie count is higher than the show in content that is available for the data analysis in data set, right? The conclusion, so it is very important. As I did the analysis, so basically the primary focus should on better variety, clear content info, high quality shows. It can grow faster, keep viewers happy. Should add more shows. Why should add more shows? Because we saw that after 2000 how shows are evolving, and they are getting good IMDb rating as compared to movies. Also we have movies count high in Amazon Prime library, but shows are getting more IMDb score. So we need to focus on shows also. We found that TV shows with more seasons also often have higher ratings, right? So we need to make more seasons, so user engagement will increase. Important finding was about IMDb score. Most shows had score 6 to 7, which means the content is okay but not great. So Amazon should improve the quality of the shows by focusing on the better stories, acting, or production. Or we can have the different shows, movies from different regions, so people will be getting more curious, or right, more curious about those content also. Many shows do not have age rating. Amazon should make sure that all shows have clear age certification, because if we are having content for every age group, so basically viewers will increase, and Amazon Prime library platform will increase. Amazon should add more shows other countries to get more viewers from around the world, that I already talked about. Avoiding too many mixed genre in one show, because in one show it could be not for shows, but it should be moved for the movies, because we saw that if shows are having more than one genre, then it would might confuse the viewer. But if a show, because we are having like number of seasons, so we can focus on different genres in every season, right? So basically we need to focus on clear content, reason, and fast, how we can just add more shows, a certification, all things that I needed, I wrote down in the conclusion section. So this was all about the Amazon Prime Video dataset exploratory data analysis. I want to add one more point here, that actually I was having more than 10 visualization, and I did explain every graph, but the length for this video is going up what was expected and what was written in project guidelines, so I need to edit it. I hope that I would be able to make you understand every chart and how we have wrangled the data. So thank you so much for your time.